Quantifying Centroid locations in the DataRay software is very easy. We offer both relative and absolute measurements, as well as various different Centroid definitions. At the bottom left of the screen, you'll notice a blue button that says Centroid Absolute. This is the software letting you know that you're measuring an absolute centroid. So everything is in reference to the center of the sensor, which is the 0, 0 coordinate. The X, Y, and R, these are your centroid positions. If you have a negative X value, you're on the left side of the sensor. If you have a negative Y value, you're on the bottom part of the sensor. And R is just a straight line from the origin to that centroid location. If I click the Centroid Absolute button, you'll notice it now says Centroid Relative. Both X, Y, and R have now been zeroed out, and you can measure changes in the centroid. If I move my profiler slightly, you'll notice now I've measured the change in that centroid. This is great for finding out if your beam has drifted over time or if it's moved at all. In addition to the absolute and relative measurements, there's also several different centroid definitions that you can use. These are accessed to the top of the screen by XC, XG, XP, and XU. XC is the default behavior. It's a weighted geometric centroid. What I mean by that is the software looks at all the illuminated pixels and weighs the pixel position based off of how bright the pixel is. In other words, brighter pixels will contribute more to the centroid location than darker pixels. It's also important to note that you can change the clip level for this centroid. If you want to change this clip level, you can go to Setup, Set Centroid Clip Level. By default, it's set to 1 over e squared, but you can change it to whatever you'd like. The next centroid definition is the geometric centroid, or XG. This is similar to the previous centroid definition, but it doesn't weigh the brighter or darker pixels into the calculation. Essentially, it's just looking at the pixels that are illuminated within the beam and using that to find the centroid. If you'd like to change the clip level of this measurement, you go to Setup, Set Geocentroid Clip Level. Again, the default's 1 over e squared, but you can change it to whatever you'd like. XP is the peak centroid level. This will always point to the hottest pixel in the beam profile. You'll notice in my software that the pixel's jumping around. That's because the hottest pixel is changing in real time. XU is a user centroid. I can click anywhere in the 2D plot and change the centroid position. This is particularly useful for the one-dimensional profiles. You'll notice as I move the centroid, it's actually changing where the one-dimensional profiles are read out from. It's also important to note that I can change the orientation and position of these crosshairs as well. If I right-click the 2D plot, I can auto-orient the crosshairs to the major and minor. I can force them to 0 degrees, 45 degrees, or 90 degrees. If you don't want to use any of these predefined angles, you can also unselect all of the options and then simply click and drag the edge of the crosshair.